Hi, my name is Ryan Verrett, and I'm at Autotestcon 2011, and I'm here to show you a quick demonstration of NI FlexRIO for digital test. So what we have here today is a PXI chassis with an NI FlexRIO FPGA module and an NI 6585 LVDS digital adapter module. And what we're actually testing is this UUT here, which is basically acting as a digital subsystem, and it allows us to demonstrate some different capability of our FlexRIO FPGA platform. Okay, so our first test that we're demonstrating here today is a basic loopback test where on our FPGA module in our PXI chassis, we're synthesizing a pseudo-random bit sequence. We're transmitting it to the UUT, and the UUT is looping it back and basically sending the data right back to the FPGA module. Then on the FPGA, we're actually doing a comparison of the transmitted and received data to ensure that they are the same in calculating the bit error rate. So if I restart my test, we're testing very quickly, actually, multiple gigabits per second of data. The interface is actually 16 bits, 200 megahertz LVDS. And I can actually flip a switch on my UUT to introduce errors into the digital data stream. And you can see that they're detected by the FPGA, counting the number of individual bit errors all in real time and also calculating the bit error rate. So that's basically the first test. We can extend that, switching off the errors on the UUT, and we could also sweep the frequency of our interface, going up from 160 megahertz to the design limit of 200 megahertz, basically to ensure that we are, in fact, passing and meeting all the specifications of the interface. So we've got 0 bit errors across the frequency range. Now we can actually extend the capabilities of our basic bit error rate test by implementing a protocol, a communications protocol, between our FPGA module and our UUT. And here, what we're doing is we're basically adding a Hamming code to the transmitted data on the FPGA module. The UUT is decoding that Hamming protocol, re-encoding it, and then sending it back to the FPGA where we perform a comparison. And here I can go ahead and flip my switch on the UUT to inject errors, and you can see that there are no errors detected because we're injecting errors on top of the Hamming error correcting code so that we can recover from all of those bit errors. Now if I disable my protocol and go back to the pseudo-random bit sequence, you can see that we are not recovering from those errors any longer, and we're actually catching errors in our transmitted data. On our next tab, we're actually doing a functional test of our UUT, where we're basically running some calculations on the UUT as well as the FPGA tester and confirming that the result is the same on both the UUT and the tester. So oftentimes in digital designs, you'll not only create your design, but you'll also create a test bench for your design. And here we're basically showing how you can deploy that test bench onto NI FlexRIO FPGA test hardware to, instead of simulating your design and simulating your tests, actually performing real-world test of the completed design. And we're doing that at a much, much higher rate than you would with a simulation. And we're actually testing every possible permutation of inputs to our algorithm to ensure complete functional verification. And we can also inject errors at the end here. I'll run it again by flipping our switch to show that if we're not performing the calculation correctly on the UUT, we are in fact detecting that on the FPGA. The UUT in this case also has some memory, 128 megabytes, and we can actually generate a walking ones, walking zeros test pattern to basically test every cell of the memory. And you can see that's done in very short order. We can enable errors, and you see we get a few bad cells detected in our test. And then finally, let's assume that this UUT is in fact a video subsystem. And here we can show how we're looping back raw digital pixels and digital frames of video data through the UUT and then getting it back on our test system to verify the video data. This data is actually being streamed from the NI 8260 in-chassis storage module at a rate of about 100 megabytes per second, and we're basically just displaying it And we can also show how, again, if we inject errors into the signal, we see those on the digital display here as bit errors, these kind of wavy lines across the picture here. So again, we just showed a brief demonstration of FlexRIO FPGA technology and how it can be used to test digital devices with real-time performance and analysis, complete test coverage, and basically the ability to adapt the test hardware to the particular device under test. Thank you very much.